Now observing 55 Cancri E. 55 Cancri E is an extremely dense super-Earth that orbits its Sun-like parent star at an incredibly close distance, completing an orbit in just 18 hours. Due to this proximity, its surface temperature reaches nearly 2,400 degrees Celsius, which is hot enough to melt most metals. The planet is likely tidally locked, featuring a permanent dayside consisting of a vast churning ocean of molten magma. Because of its high carbon content and the intense internal pressure, some astrophysical models suggest that up to 1/3 of the planet's mass could be composed of solid diamond. Now observing PSR B1257 plus 12. PSR B1257 plus 12, colloquially named Lich, is a rapidly rotating neutron star that completes a full rotation every 6.22 milliseconds. It gained scientific fame as the first system discovered to host extrasolar planets, with 3 rocky worlds identified orbiting this dead stellar remnant. These planets endure a continuous bombardment of high-energy radiation and relativistic particles emitted from the pulsar's magnetic poles. The planets in this system are likely second-generation worlds, formed from the recycled remains of a companion star that was completely shredded by the pulsar's immense gravity and radiation. Now observing WR124. WR124 is an extremely rare and luminous star undergoing a brief final stage before exploding as a supernova. It is characterized by its intense stellar winds that have ejected massive amounts of material into the surrounding space, creating the nebula M1-67. This resulting halo is a chaotic display of glowing gas clumps and complex dust structures shaped by the star's fierce radiation. The nebula surrounding WR124 contains dust and gas equivalent to the mass of 10 suns, all ejected in just the last 10,000 years. Now observing V838 Monoceratodus. V838 Monoceratodus is a red variable star that became famous for a major outburst in 2002, which created a spectacular light echo. This phenomenon occurred as light from the sudden eruption reflected off surrounding shells of interstellar dust, making the star appear to expand rapidly over time. It is currently classified as an L-type supergiant and is one of the largest and most luminous stars known during its peak flare-ups. The expansion of the nebula seen in images is an optical illusion. The dust was already there, and we are simply seeing light from the 2002 flash hitting more distant parts of the cloud. Now observing SGR 1806-20. SGR 1806-20 is an ultra-dense magnetic tar with a magnetic field strength estimated at 10 to the 15th Gauss, making it one of the most magnetic objects in the known universe. This neutron star is the collapsed remnant of a massive star, packing more mass than the Sun into a sphere only 12 miles wide. In 2004, it emitted a record-breaking gamma-ray flare that physically altered Earth's upper atmosphere from 50,000 light-years away. It remains a primary subject of study for understanding the extreme physics of degenerate matter and high-energy electromagnetism. The magnetic field of SGR 1806-20 is so powerful that it would strip the information from every credit card on Earth from a distance halfway to the Moon. Now observing ARP 273. ARP 273 is a stunning pair of interacting galaxies, primarily composed of the larger spiral UGC 1810 and its smaller companion UGC 1813. The gravitational tidal forces from the smaller galaxy have distorted the larger one into a shape resembling a cosmic rose, with its spiral arms pulled into delicate petal-like structures. This intense gravitational interaction has triggered a burst of star formation, visible as brilliant blue clusters of young, hot stars along the outer edges. The smaller galaxy, UGC 1813, shows a distinctively bright core, suggesting that it has actually plunged through the outer arms of the larger galaxy to create this floral appearance. Now observing Sombrero Galaxy, Messier 104. The Sombrero Galaxy is a striking lenticular galaxy featuring a massive, luminous central bulge and a thick, well-defined dust lane cutting across its disk. Its appearance from Earth is nearly edge-on, revealing a structure that mimics the shape of a wide-brimmed hat. At its heart lies a supermassive black hole with a mass equivalent to approximately 1 billion suns. The Sombrero Galaxy contains an unusually large system of globular clusters, hosting nearly 2,000 of these ancient star groups, which is about 10 times more than the Milky Way. Now observing M87 star. M87 star is a supermassive black hole located at the heart of the giant elliptical galaxy Messier 87. It gained global fame as the first black hole ever to be directly imaged by the Event Horizon Telescope, revealing a glowing ring of superheated gas. This cosmic titan has a mass equivalent to approximately 6.5 billion suns and powers a massive relativistic jet that extends thousands of light years into space. The event horizon of M87 star is so vast that it is larger than the entire orbit of Pluto around our Sun. Now observing Hoag's object. Hoag's object is a rare and enigmatic non-typical galaxy consisting of a nearly perfect ring of young, hot blue stars surrounding a yellow nucleus. The gap between the central core and the outer ring is remarkably clear, though it may contain faint star clusters. This formation challenges standard galactic evolution theories, as its symmetrical structure does not fit the typical spiral or elliptical categories. Peering through the gap between the core and the outer ring reveals another, even more distant ring galaxy, a phenomenon nicknamed the cosmic photobomb. Now observing WASP-12b. WASP-12b is a gas giant exoplanet that orbits its host star so closely that it is being tidally distorted into an egg-like shape. The intense gravitational pull of the star is stripping away the planet's atmosphere, forming a luminous disk of material around the stellar surface. With surface temperatures reaching approximately 2200 degrees Celsius, it is one of the hottest and most doomed planets currently known. This extreme proximity causes the planet to complete a full orbit in just over one Earth day. WASP-12b is being eaten by its parent star at a rate of about 189 quadrillion tons of gas per year, meaning the planet likely has only 10 million years of life remaining. Now observing Gliese 436b. Gliese 436b is a Neptune-sized exoplanet orbiting a red dwarf star at an incredibly close proximity, completing a full orbit in just 2.6 Earth days. Despite its scorching surface temperatures of nearly 800 degrees Fahrenheit, the planet's immense gravity compresses its water content into a high-pressure solid state known as hot ice or Ice X. Additionally, the planet is trailed by a colossal cloud of hydrogen gas, creating a comet-like tail that stretches millions of kilometers through space. The planet's massive hydrogen tail, nicknamed the Behemoth, is so large that it blocks significant portions of the host star's light, making the planet appear much larger than it actually is in ultraviolet wavelengths. Now observing TRES 2b. TRES 2b is an extraordinarily dark exoplanet that reflects less than 1% of the light that hits it, making it blacker than coal or acrylic paint. This massive gas giant orbits its host star at a distance of only 5 million kilometers, leading to scorching atmospheric temperatures of around 1000 degrees Celsius. Scientists believe the lack of reflective clouds and the presence of light-absorbing chemicals like vaporized sodium and potassium contribute to its ink-black appearance. This planet is so dark that if it were visible to the human eye, it would look like a black ball of gas with a faint, eerie red glow emanating from its intense heat. Now observing Boomerang Nebula. The Boomerang Nebula is a young protoplanetary nebula formed by a dying red giant star shedding its outer layers into space. It is characterized by its symmetrical, dual-lobed shape, created by high-speed winds of gas expanding outward at approximately 164 kilometers per second. This rapid expansion has caused the nebula to undergo significant adiabatic cooling, making it the coldest known natural environment in the observable universe. The internal temperature of the Boomerang Nebula is a mere 1 Kelvin, which is actually colder than the cosmic microwave background radiation left over from the Big Bang. Now observing Tarantula Nebula. The Tarantula Nebula is the largest and most intense star-forming region discovered within the local group of galaxies. Spanning approximately 600 light-years across, its massive structure is continuously shaped by the extreme radiation and stellar winds of the superstar cluster R136 at its core. This region serves as a crucial laboratory for astronomers to study the life cycle of stars and the evolution of massive galactic structures. If the Tarantula Nebula were located at the same distance from Earth as the Orion Nebula, it would cover half the sky and be bright enough to cast visible shadows at night. Now observing Kelt 9b. Kelt 9b is the hottest known gas giant exoplanet, possessing a dayside temperature that exceeds 4,600 Kelvin. It orbits its massive A-type host star every 1.5 days, resulting in such intense radiation that the planet's atmosphere is being stripped away into space. The extreme thermal environment is so severe that molecules like water and carbon dioxide cannot form, leaving an atmosphere primarily composed of atomic metals like iron and titanium. At its peak temperature, Kelt 9b is hotter than the surface of nearly 80% of all known stars in the universe. Now observing Cassiopeia A. Cassiopeia A is the youngest known supernova remnant in the Milky Way, resulting from a massive star that exploded approximately 340 years ago. It consists of a complex, expanding shell of gas and dust, heated to millions of degrees by powerful shockwaves. This remnant serves as a crucial celestial laboratory for understanding how supernovae disperse heavy elements, like iron and oxygen, throughout the galaxy. The light from the original supernova likely reached Earth in the late 17th century, yet there are no definitive historical records of it being seen, possibly due to thick interstellar dust obscuring the event. Now observing Cartwheel Galaxy. The Cartwheel Galaxy is a rare and striking lenticular galaxy formed by a high-speed collision between a large spiral galaxy and a smaller companion. This cosmic impact sent a massive shockwave through the galaxy's interstellar gas and dust, triggering intense star formation in an expanding outer ring. The central core remains intact, connected to the outer ring by spokes of gas, creating its iconic wagon wheel appearance. Despite the violent collision that created its shape, the Cartwheel Galaxy is approximately 150,000 light-years across, making it slightly larger than our own Milky Way. Now observing Stephenson 2-18. Stephenson 2-18 is currently the largest known star in the universe, boasting a radius approximately 2,150 times that of the Sun. If placed at the center of our solar system, its photosphere would engulf the orbit of Saturn and potentially even reach the orbit of Uranus. This extreme red hypergiant resides within the massive open cluster Stephenson 2 and serves as a primary example of the upper limits of stellar volume. Traveling at the speed of light, it would take nearly 9 hours to circumnavigate the star's equator, compared to only 14.5 seconds for the Sun. Now observing HR 5171a. HR 5171a is one of the 10 largest stars currently known, possessing a radius approximately 1,300 times that of the Sun. This rare stellar object exists in a brief evolutionary phase, characterized by extreme instability and massive atmospheric loss. It belongs to a contact binary system, where its smaller companion is so close that the two stars share a common envelope of gas. This hypergiant is so large that if it were placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. Now observing J05294351. J05294351 is a record-breaking quasar powered by a supermassive black hole growing at an unprecedented rate. It is recognized as the most luminous object currently known in the universe, emitting radiation equivalent to over 500 trillion suns. The central black hole has an estimated mass of 17 billion solar masses and consumes approximately 1 sun's worth of material every day. This extreme accretion process makes it a crucial laboratory for studying the early universe's evolution. The accretion disk surrounding this black hole is the largest in the universe, measuring 7 light-years in diameter, roughly 15,000 times the distance from the Sun to Neptune. Now observing Earendel, WHL0137LS. Earendel is currently the most distant individual star ever observed, seen as it existed only 900 million years after the Big Bang. Its light has been magnified by a factor of thousands through the gravitational lensing effect of the massive foreground galaxy cluster WHL0137-08. This massive star is estimated to be at least 50 times the mass of the Sun and millions of times as bright, providing a rare glimpse into the early universe. Its name comes from an Old English word meaning morning star or rising light, and its discovery was only possible because it happened to align perfectly with a ripple in space-time called a caustic. Now observing HD 189733b. HD 189733b is a massive gas giant that orbits its parent star at an incredibly close distance, completing a full revolution in just 2.2 days. Its atmosphere is characterized by extreme temperatures, exceeding 1,000 degrees Celsius, and howling winds that reach speeds of up to 2 kilometers per second. The planet's striking deep blue color is believed to be caused by high-altitude clouds laced with silicate particles, which scatter blue light more efficiently than red. Observations have revealed that this world experiences dramatic evaporation, with its atmosphere bleeding into space due to intense stellar radiation. On this planet, the weather forecast often includes sideways rain made of molten glass, driven by sonic winds that carry the silicate particles across the globe.
Now observing PSR J07373039. PSR J07373039 is the first and only known binary system composed of two pulsars orbiting a common center of mass. Discovered in 2003, these two highly magnetized neutron stars complete an orbit every 2.4 hours at speeds reaching 0.1% the speed of light. This rare configuration provides a unique natural laboratory for testing the predictions of Albert Einstein's general theory of relativity in extremely strong gravitational fields. The system is losing so much energy through the emission of gravitational waves that the two pulsars are spiraling toward each other and will eventually collide in about 85 million years.
Now observing IC 1101. IC 1101 is one of the largest known galaxies in the observable universe, spanning approximately 6 million light-years in diameter. Located at the core of the Abell 2029 galaxy cluster, it contains an estimated 100 trillion stars, dwarfing the Milky Way's population. This gargantuan cosmic structure is primarily composed of old, metal-rich stars and has achieved its immense size through the gravitational merger of thousands of smaller galaxies over billions of years. IC 1101 is so fast that if it were placed where the Milky Way is, its outer edges would reach far beyond our neighbor, the Andromeda Galaxy, which is 2.5 million light-years away.
Now observing V838 Monocerotis. V838 Monocerotis is a red variable star that gained fame after a sudden, massive outburst in 2002. During this event, the star expanded to a gargantuan size, briefly becoming one of the most luminous objects in our galaxy. The most striking feature is the light echo, where shells of circumstellar dust are illuminated by the pulse of light traveling outward from the star. While it appeared to be expanding, the dust shell around the star was already there. We only saw it because the light from the 2002 explosion finally reached it and bounced back toward Earth. Now observing Mira, Omicron Cedae. Mira is a pulsating red giant star that serves as the prototype for a class of long-period variable stars. It is part of a binary system with a white dwarf companion, Mira B, which accretes matter from the primary star's stellar wind. As Mira moves through the interstellar medium at supersonic speeds, it sheds its outer layers, creating a spectacular tail of gas. Mira possesses a comet-like tail of shed material that stretches approximately 13 light-years in length, a feature that remained invisible until observed in ultraviolet light by the Galax spacecraft. Now observing R136A1. R136A1 is currently the most massive and luminous star known in the observable universe, residing within the R136 star cluster. It belongs to a rare class of Wolf-Rayet stars characterized by intense stellar winds and surface temperatures exceeding 50,000 Kelvin. This hypergiant is so massive that it challenges existing models of stellar formation, sitting near the theoretical limit for how large a star can become. If R136A1 replaced the Sun in our solar system, its extreme luminosity would be nearly 9 million times brighter, making the Earth's surface hotter than the Sun's core and causing the planet to vanish instantly.
Now observing Thor's helmet, NGC 2359. Thor's helmet is a massive emission nebula blown by the powerful stellar winds of a central Wolf-Rayet star. This energetic star, known as WR7, is in a brief pre-supernova stage, shedding its outer layers at speeds of several million miles per hour. The nebula's complex structure, featuring a central bubble and wing-like appendages, is formed as the expanding gas interacts with a nearby molecular cloud. Its distinct shape and ionization levels provide astronomers with critical data on the evolution of high-mass stars. The central star, WR7, is estimated to be over 280,000 times more luminous than our Sun and is currently losing mass at a rate that could consume an entire Earth's mass every few years.
Now observing Messier 104, Sombrero Galaxy. Messier 104 is an unbarred spiral galaxy characterized by its unusually large central bulge and a thick, opaque ring of interstellar dust. At its heart lies a supermassive black hole exceeding 1 billion solar masses, which is significantly more massive than the one found in our own Milky Way. Its distinct morphology, seen nearly edge-on, makes it a primary subject for studying galactic structure and the evolution of massive globular cluster systems. The Sombrero Galaxy contains almost 2,000 globular clusters, which is 10 times more than the number orbiting the Milky Way, hinting at a very violent history of galactic mergers.
Now observing PSR B150958. PSR B150958 is a rapidly spinning neutron star that powers a vast nebula of energized particles through its intense magnetic field. The pulsar itself is approximately 1,700 years old and rotates nearly 7 times every second, injecting enormous amounts of energy into its surroundings. This process creates a massive glowing structure of high-energy X-rays that spans roughly 150 light-years across the interstellar medium. The nebula's eerie resemblance to a human hand has earned it the nickname the Hand of God, though the shape is actually formed by pulsar wind-driven particles interacting with nearby gas clouds.
Now observing Hani's Voorwerp. Hany's forewarp is a rare cosmic phenomenon known as a quasar ionization echo, located near the spiral galaxy IC 2497. It consists of a massive, glowing green cloud of gas that was illuminated by a burst of radiation from a now dormant supermassive black hole. This enormous gas structure is primarily composed of hydrogen and glows through the process of photoionization from the nearby galaxy's active past. The object features a large central hole and intricate filaments spanning over 35,000 light-years in diameter. It was discovered in 2007 by Hanny van Arkel, a Dutch schoolteacher, while she was participating in the Galaxy Zoo Citizen Science Project. Now observing Hoag's object. Hoag's object is a non-typical galaxy consisting of a nearly perfect ring of young, hot blue stars surrounding a much older yellow nucleus. This structure is exceptionally rare, as most galaxies are either spiral or elliptical, yet there is no visible connection between the core and the outer ring. The formation of this object remains a subject of intense debate, with theories ranging from a galactic collision to a slow gravitational process over billions of years. Deep within the empty space between the yellow core and the blue ring, another, much more distant ring galaxy is visible in the background, making it a cosmic ring within a ring coincidence.
Now observing GJ1214b. GJ1214b is a significant super-Earth orbiting a small red dwarf star, characterized by its likely high water content and thick atmosphere. Observations suggest this world is covered by a deep global ocean and encased in a dense layer of steam and water vapor. Given the extreme pressures and temperatures present, the water likely exists in exotic states, such as supercritical fluid or high-pressure ice. The planet is so hot and pressurized that its water may take the form of hot ice, a substance that remains solid despite temperatures exceeding several hundred degrees Celsius. Now observing Boomerang Nebula. The Boomerang Nebula is a young protoplanetary nebula formed by a dying central star shedding its outer layers into space. It is distinguished by its ultra-fast outflowing gas, which has expanded so rapidly that it cooled to temperatures lower than the cosmic microwave background radiation. This unique thermodynamic state makes it the coldest naturally occurring place known in the entire universe. At a temperature of only 1 Kelvin, which is roughly -458 degrees Fahrenheit, this nebula is actually colder than the empty space that surrounds it. Now observing Centaurus A, NGC 5128. Centaurus A is one of the closest radio galaxies to Earth, featuring a massive central black hole that powers an extremely active nucleus. It is uniquely characterized by a prominent, thick dust lane that bisects its elliptical shape.
which scientists believe is a remnant of a collision with a smaller spiral galaxy millions of years ago. The galaxy emits powerful jets of plasma that extend thousands of light years into intergalactic space, making it a primary target for multi-wavelength astrophysical research. The central supermassive black hole in Centaurus A has a mass equivalent to approximately 55 million suns. Now observing WASP-12b. WASP-12b is a gas giant exoplanet orbiting so close to its host star that it is being tidally stretched into an oblong, egg-like shape. The intense gravity of the star is actively stripping material from the planet's atmosphere, creating a luminous disk of matter spiraling inward. This extreme proximity results in scorching surface temperatures exceeding 2200 degrees Celsius, making it one of the hottest and most doomed worlds ever discovered. Due to the relentless tidal forces and atmospheric stripping, WASP-12b is being consumed by its star and is predicted to vanish entirely within just 10 million years. Now observing the Red Rectangle Nebula. The Red Rectangle Nebula is a striking protoplanetary nebula known for its unique biconical structure that appears as a geometric X-shape from our perspective. It surrounds a binary star system at its center, which provides the energy needed to illuminate the intricate rungs of dust and gas extending outward. The nebula is famous for its high concentration of polycyclic aromatic hydrocarbons, which emit a mysterious red glow known as extended red emission. The distinct ladder rungs visible in the nebula are actually shocks caused by periodic outbursts of gas from the central stars, occurring roughly every few hundred years. Now observing Helix Nebula, NGC 7293. The Helix Nebula is a classic example of a planetary nebula, formed by the outer layers of a dying sun-like star being expelled into space. As the central star evolves into a white dwarf, its intense ultraviolet radiation causes the surrounding gas to glow in vibrant colors. This intricate structure provides astronomers with a detailed look at the final stages of stellar evolution for medium-mass stars. Its proximity to Earth makes it one of the most studied and visually detailed objects of its kind. The nebula contains thousands of cometary knots, which are dense clumps of gas and dust with tails pointing away from the central star, each one larger than our entire solar system. Now observing NGC 1999. NGC 1999 is a striking reflection nebula located in the constellation Orion, famous for its distinct T-shaped dark patch. While it was once thought to be a dense cloud of gas and dust, infrared observations have confirmed that this central dark region is actually a completely empty hole in space. The nebula is illuminated by the intense light of V380 Orionis, a young star that has likely used its powerful stellar winds and radiation to clear out the surrounding cavity. For decades, astronomers believed the central dark patch was a dense globule of matter blocking light, but it was later proven to be a literal, empty hole in the nebula's structure. Now observing PSR J1748-2446 AD. PSR J1748-2446 AD is the fastest spinning pulsar currently known, rotating at an incredible speed of 716 times per second. This neutron star possesses a density so extreme that a single teaspoon of its material would weigh more than Mount Everest. Its rapid rotation causes its equator to move at approximately 24. Now observing Bernardinelli Bernstein, C 2014 UN 271. Bernardinelli Bernstein is a record-breaking megacomet originating from the distant Oort cloud, possessing a nucleus roughly 85 miles wide. Unlike typical comets, its massive size makes it more comparable to a small planetoid, yet it displays clear cometary activity through the sublimation of ices. It is currently on a multi-million-year orbit that will bring it to its perihelion just beyond the orbit of Saturn in 2031. Its nucleus is approximately 50 times larger than the average comet and is estimated to be 100,000 times more massive than a typical comet, like 67P Churyumov-Gerasimenko. Now observing Cassiopeia A. Cassiopeia A is the youngest known supernova remnant in the Milky Way, resulting from a massive star's explosive death approximately 330 years ago. It consists of a hot, expanding shell of gas and dust that continues to glow across multiple wavelengths, particularly in X-rays. At its heart lies a neutron star, which was only discovered decades after the remnant itself was identified. Despite being one of the brightest radio sources in the sky, the supernova that created it was likely so obscured by interstellar dust that it may have gone largely unnoticed by 17th century astronomers. Now observing ARP 273. ARP 273 is a stunning pair of interacting galaxies located in the northern constellation Andromeda. The larger of the two spiral galaxies, known as UGC 1810, has a disk that is tidally distorted into a rose-like shape by the gravitational pull of the companion galaxy, UGC 1813, below it. This cosmic dance is characterized by a bridge of material connecting the two and intense bursts of star formation triggered by their close encounter. The larger galaxy actually has a mass about 5 times greater than its smaller companion, which causes the asymmetrical spiral arm to wrap almost entirely around the smaller galaxy's core.
Now observing Messier 82, Cigar Galaxy. Messier 82 is a renowned starburst galaxy characterized by a rate of star formation 10 times higher than that of the Milky Way. This intense activity is driven by a past gravitational encounter with its neighbor, M81, which compressed gas clouds deep within its core. Large plumes of ionized hydrogen gas are being ejected from the center, creating a spectacular red glow that extends thousands of light years into intergalactic space. The starburst in M82's core is so dense that supernova explosions occur approximately once every 10 years, providing a natural laboratory for studying cosmic ray acceleration. Now observing Wolf-Rayet 124. Wolf-Rayet 124 is a massive, incredibly hot star, currently undergoing a brief but violent transition phase before exploding as a supernova. It is surrounded by the M1-67 nebula, which is composed of clumps and filaments of gas ejected by the star's intense stellar winds. These winds can reach speeds of several million miles per hour, stripping the star of its outer hydrogen layers and exposing its helium core. Wolf-Rayet 124 is one of the fastest stars in the Milky Way, hurtling through the galaxy at a velocity of approximately 200 kilometers per second. Now observing Abell 39. Abell 39 is a remarkably symmetrical and nearly perfect spherical planetary nebula representing the final stages of a sun-like star's life. The nebula consists of an expanding shell of ionized gas that was ejected by its central star thousands of years ago. Spanning roughly 5 light-years in diameter, it is one of the largest and most ideal examples of a spherical cosmic bubble known to astronomers. Despite the nebula's nearly perfect spherical symmetry, its central star is mysteriously offset from the geometric center by about 0.1 light-years. Now observing V838 monoceratosis. V838 monoceratosis is a red variable star that underwent a massive outburst in 2002, briefly becoming one of the most luminous stars in the Milky Way. This event produced a spectacular light echo as the flash of radiation reflected off pre-existing shells of interstellar dust. The resulting imagery shows a complex, expanding structure of illuminated gas that provides critical insights into the star's late-stage evolutionary behavior. The expanding light echo around the star created a geometric illusion that made it appear to be moving at speeds exceeding that of light, a phenomenon known as superluminal motion. Now observing WASP-76b. WASP-76b is an ultra-hot gas giant tidally locked to its parent star, creating extreme temperature differentials between its day and night sides. On the day side, temperatures soar above 2,400 degrees Celsius, sufficient to vaporize metals like iron.
High-speed winds carry this iron vapor to the cooler night side, where it condenses and falls as liquid metallic rain. The planet's atmosphere is so hot that it causes molecular iron to evaporate into a gas on the day side before condensing into liquid metal rain on the night side. Now observing Tarantula Nebula, 30 Doradus. The Tarantula Nebula is the largest and most active star-forming region in the local group, spanning over 600 light-years across. It is characterized by its massive clouds of ionized hydrogen and a central ultra-dense star cluster called R136 that emits fierce ultraviolet radiation. The nebula's complex structure is shaped by the powerful stellar winds and supernovae of the exceptionally massive stars residing within its core. If the Tarantula Nebula were located at the same distance from Earth as the Orion Nebula, it would be so large that it would cover 60 degrees of the sky and cast visible shadows on the ground at night.
Now observing Cartwheel Galaxy. The Cartwheel Galaxy is a rare ring galaxy formed by a high-speed collision between a large spiral galaxy and a smaller companion. This cosmic impact sent shockwaves through the galaxy's gas and dust, triggering intense star formation and creating its distinctive wheel-like appearance. The outer ring, which has expanded for hundreds of millions of years, is dominated by massive young stars and supernova remnants. The outer ring of the Cartwheel Galaxy is approximately 150,000 light-years in diameter, making it significantly larger than our entire Milky Way galaxy.
Now observing WASC 107b. WASC 107b is a gas giant exoplanet that challenges our understanding of planetary formation due to its incredibly low density, often compared to cotton candy. It orbits a K-type star and has a mass similar to Neptune, but a volume nearly equal to Jupiter. Recent observations by the James Webb Space Telescope have identified sulfur dioxide, water vapor, and silicate sand clouds in its atmosphere. This planet experiences a unique sand cycle where silicate particles evaporate in the hot lower atmosphere, rise to cooler levels to form clouds, and then rain back down as solid sand.
Now observing PSR B1257 plus 12, Lich.
PSR B1257 plus 12 is a rapidly rotating neutron star that emits intense beams of electromagnetic radiation from its magnetic poles, like a cosmic lighthouse. This stellar remnant rotates 161 times per second and is famous for being the first star of any kind found to host planets. These planets, named Draugr, Poltergeist, and Phobetor, likely formed from a disk of debris left over after the original star exploded in a supernova. The planets orbiting this pulsar were the first exoplanets ever confirmed to exist, discovered 3 years before the first exoplanet around a sun-like star. Now observing Hoag's object. Hoag's object is a non-typical galaxy featuring a nearly perfect ring of young, hot blue stars surrounding a much older yellow core. The gap between the central nucleus and the outer ring appears almost entirely transparent, containing very little observable matter. This unique structural configuration defies standard galactic classification and continues to intrigue astronomers regarding its formation and stability. Through the gap of the galaxy's ring, a second, even more distant ring galaxy is visible in the background at the 1 o'clock position, creating a rare cosmic coincidence. Now observing GJ504b. GJ504b is a massive gas giant orbiting the sun-like star GJ504, notable for being one of the few exoplanets ever captured via direct imaging. Despite its age, it remains much hotter than Jupiter, suggesting it formed through a process that retained significant internal energy. Scientists study its relatively clear atmosphere to understand the chemistry of giant planets that exist far from their host stars. Because it is still glowing with the residual heat from its formation, GJ504b would appear to the human eye as a striking shade of deep cherry blossom pink or dark magenta. Now observing Herbig-Haro 24, HH24. Herbig-Haro 24 is a spectacular manifestation of a newborn star undergoing an intense period of growth. It features 2 highly collimated, narrow jets of partially ionized gas being ejected from the poles of a deeply embedded protostar. As these supersonic jets collide with the surrounding dense molecular cloud, they create glowing shock fronts that illuminate the otherwise dark and dusty environment. Because the central protostar is completely obscured by a thick disk of gas and dust, the 2 symmetrical jets appear to emerge from empty space, strikingly resembling a double-bladed lightsaber from Star Wars. Now observing Stephenson 218. Stephenson 218 is currently one of the largest known stars in the universe, with a radius roughly 2,150 times that of our Sun. If placed at the center of our solar system, its photosphere would extend beyond the orbit of Saturn. This massive star is part of the Stephenson 2 open cluster and represents an extreme stage of stellar evolution for high-mass stars. If you were to travel around the circumference of Stephenson 218 at the speed of light, the journey would take approximately 8.7 hours, whereas the same trip around our Sun would take only 14.5 seconds. Now observing ESO 137-001. ESO 137-001 is a barge spiral galaxy undergoing a violent process called ram pressure stripping as it plunges through the hot gas of the Norma cluster at millions of miles per hour. This motion forces the galaxy's own internal gas out into space, creating long, luminous tentacles of gas and young stars that stretch over 260,000 light-years. As the galaxy loses its cold gas to the surrounding cluster medium, it effectively loses the raw material needed to form future generations of stars. The trailing tentacles of this galaxy actually contain hundreds of orphaned young blue stars that formed in the chaos of the stripped gas, far outside the boundaries of the galaxy itself.
Now observing Boomerang Nebula. The Boomerang Nebula is a young pre-planetary nebula formed by the rapid outflow of gas from a central dying star. It is remarkably known as the coldest natural place in the universe, with a temperature of approximately 1 Kelvin, which is even colder than the cosmic microwave background radiation. The extreme cooling is caused by the adiabatic expansion of gas moving at speeds of about 164 kilometers per second. This nebula is so cold that it actually absorbs heat from the cosmic microwave background radiation, making it the only object currently known that is colder than the afterglow of the Big Bang.
Now observing HD 189733b. HD 189733b is a gas giant exoplanet that orbits extremely close to its host star, resulting in a tidally locked world with temperatures exceeding 1,000 degrees Celsius. Its striking deep blue appearance is caused by silicate particles in its atmosphere that scatter blue light more efficiently than red. This planet is a place of meteorological extremes, featuring howling winds that move at 7 times the speed of sound. The planet features a terrifying weather system where it rains molten glass sideways at speeds of over 5,400 miles per hour.
Now observing TON 618.
TON 618 is an extremely luminous quasar containing one of the most massive black holes currently known to science, estimated at 66 billion times the mass of our Sun. This ultra-massive black hole is fueled by a colossal accretion disk of swirling gas that emits intense radiation, outshining its host galaxy from across the observable universe. The object serves as a critical benchmark for astrophysicists studying the upper mass limits of black holes and the evolution of the early cosmos. The event horizon of this black hole is so vast that it has a diameter of approximately 390 billion kilometers, which is more than 40 times the distance from the Sun to Pluto. Now observing SGR 180620. SGR 180620 is an ultra-dense neutron star with a magnetic field roughly a quadrillion times stronger than Earth's. It is classified as a soft gamma repeater because it periodically emits massive bursts of high-energy radiation due to starquakes on its rigid crust. This stellar remnant packs more than the mass of the Sun into a sphere only about 20 kilometers in diameter, representing one of the most extreme environments in the known universe. In 2004, a giant flare from this object released more energy in 1/10 of a second than the Sun produces in 150,000 years, momentarily physically altering Earth's upper atmosphere from across the galaxy. Now observing Lumen 16. Lumen 16 is the third closest stellar type system to the Sun, composed of two brown dwarfs that orbit each other every 25 years. These substellar objects lack the mass to sustain nuclear fusion in their cores, resulting in bodies that gradually cool and dim over billions of years. Scientific studies have identified complex, multi-layered cloud structures within their atmospheres, providing a rare glimpse into the meteorology of objects outside our solar system. Despite being the third closest system to Earth, Lumen 16 remained undetected until 2013 because brown dwarfs are extremely faint in visible light. Now observing Centaurus A. Centaurus A is one of the closest and most studied radio galaxies to Earth, characterized by its massive elliptical body bisected by a thick, dark lane of interstellar dust. This peculiar structure is the aftermath of a violent merger between a large elliptical galaxy and a smaller spiral galaxy roughly 200 million years ago. At its core, a supermassive black hole with 55 million times the mass of the Sun drives powerful relativistic jets that emit intense X-ray and radio radiation. The relativistic jets erupting from the central black hole are so colossal that they extend over 1 million light-years into intergalactic space. Now observing LP 40-365. LP 40-365 is a unique low-mass white dwarf that survived a partial Type Ia-X supernova explosion, which failed to completely destroy its progenitor star. This zombie star is composed primarily of heavy elements like neon, magnesium, and oxygen, indicating it underwent intense thermonuclear burning before the blast. It is currently traveling through the Milky Way at a staggering speed of nearly 2 million miles per hour, fast enough to eventually escape the galaxy's gravitational pull entirely. Despite being roughly the size of Earth, this star is essentially a piece of high-speed cosmic shrapnel, enriched with heavy metals from the explosion that nearly ended it. Now observing PSR J1719-1438b. PSR J1719-1438b is an exotic exoplanet that orbits an extremely dense millisecond pulsar at an incredibly close distance. Scientists believe this object is the surviving core of a white dwarf that had its outer layers stripped away by the pulsar's gravity. The extreme pressure and composition suggests the planet is largely made of ultra-dense crystalline carbon, essentially making it a planet-sized diamond. This planet orbits its parent pulsar in just 2.2 hours, and its density is so high that it is thought to be comprised of diamond-like matter. Now observing Black Widow Pulsar, PSR B1957+20. The Black Widow Pulsar is an extreme neutron star that is systematically destroying its smaller orbital companion. By emitting high-energy radiation and a powerful wind of relativistic particles, the pulsar evaporates the matter from the surface of its brown dwarf partner. This intense interaction creates a shockwave that glows across the electromagnetic spectrum, eventually leading to the total consumption of the companion star. Over millions of years, the relentless bombardment from the pulsar will completely erode its partner, until nothing remains but the lone, rapidly spinning pulsar. This pulsar spins at a staggering 622 times per second, and its companion star is so small that it is only about 0.02 times the mass of our Sun. Now observing ARP-273. ARP-273 is a stunning pair of interacting galaxies that resemble a long-stemmed rose in deep space, 1913. This gravitational dance has triggered intense bursts of star formation, visible as bright blue clusters of young stars along the outer spiral arms. The interaction provides a rare glimpse into the transformative power of galactic collisions. The larger galaxy's outer spiral arm has been pulled into a wide, thin ring because the smaller galaxy likely passed through the larger one off-center.
Now observing Messier 64, the Black Eye Galaxy. Messier 64 is a stunning spiral galaxy, famous for its spectacular dark band of absorbing dust in front of its bright nucleus. This unique feature, often called the evil eye, is the result of a merger between a small gas-rich satellite galaxy and a larger spiral companion. Unusually, the gas in its outer regions rotates in the opposite direction to the stars and gas in its inner regions. This collision-induced friction triggers intense star formation at the shear boundary between the two rotating zones. The outer gas disk of M64 rotates clockwise, while the inner disk of stars and gas rotates counterclockwise, suggesting it swallowed a neighbor about 1 billion years ago. Now observing V838 monoceratosis. V838 monoceratosis is a red variable star that underwent a massive outburst in 2002, briefly becoming one of the most luminous stars in our galaxy. This event produced a spectacular light echo as the flash of light reflected off surrounding shells of interstellar dust, creating an expanding visual display. Unlike a supernova, the star did not explode, but instead expanded to a gargantuan size, while its surface temperature dropped significantly. The expanding rings seen in famous Hubble images are not actually moving matter, but rather a pulse of light traveling through space and illuminating pre-existing dust, creating a cosmic optical illusion. Now observing Red Square Nebula, MWC 922. The Red Square Nebula is one of the most symmetrical celestial objects ever discovered, characterized by its sharp, linear edges and distinct cross-like appearance. It is a bipolar nebula formed by the outflow of gas from a central star, MWC 922, during a late stage of its evolution. The striking geometric shape is likely an optical effect caused by viewing a double cone-shaped shell of gas from a perfectly perpendicular angle. The nebula's degree of symmetry is so high that if you fold the image across its diagonal axes, the structures align almost perfectly, a rarity in the chaotic environment of deep space. Now observing J0529-4351. J0529-4351 is currently identified as the most luminous object ever observed in the universe, powered by a supermassive black hole with a mass of approximately 17 billion solar masses. This gargantuan black hole consumes the equivalent of 1 sun per day, generating an accretion disk that radiates energy at a rate 500 trillion times brighter than our sun. The extreme gravitational forces and thermal energy surrounding the core provide a rare glimpse into the violent physics of the early universe. The accretion disk surrounding the central black hole of this quasar is approximately 7 light-years in diameter, meaning it could stretch from our sun to nearly twice the distance of the nearest star. Now observing Stingray Nebula, HEN 3-1357. The Stingray Nebula is the youngest known planetary nebula, having only become visible in the last few decades as its central star rapidly heated up and ionized the surrounding gas. It represents a rare glimpse into the final stages of a medium-sized star's life, where the ejected outer layers are transformed into a glowing shell of plasma. Remarkably, recent observations from the Hubble Space Telescope show that the nebula is actually shrinking and fading in brightness, a process rarely witnessed by astronomers on such a short human timescale. The Stingray Nebula has faded by nearly 1,000 times in brightness between 1996 and 2016, suggesting it may become invisible to our telescopes within a few decades. Now observing 30 Doradus, Tarantula Nebula. 30 Doradus is the largest and most active star-forming region in the local group, characterized by its immense size and high luminosity. At its heart lies R136, a compact cluster of massive stars that radiate intense ultraviolet light and powerful stellar winds, shaping the surrounding gas into vast, spindly filaments. This cosmic nursery provides a unique laboratory for studying the life cycle of stars and the evolution of massive galactic structures. If the Tarantula Nebula were located at the same distance as the Orion Nebula, it would cover the sky as large as 60 full moons and shine bright enough to cast visible shadows on Earth. Now observing Soap Bubble Nebula. Discovered in 2008 by an amateur astronomer, the Soap Bubble Nebula is an incredibly faint and perfectly spherical planetary nebula. It was formed by a dying star that expelled its outer atmosphere into a region already rich with diffuse interstellar gas. Its remarkably thin shell and near-perfect symmetry make it look like a delicate, transparent sphere floating through the dense star clouds of the Milky Way. Despite its large apparent size, this nebula is so faint that it remained undetected by professional surveys for decades, hidden within the complex light of the nearby Crescent Nebula. Now observing Hoag's Object. Hoag's Object is a rare and enigmatic non-typical galaxy consisting of a nearly perfect circle of young, hot blue stars surrounding a luminous, older yellow core. This ring structure spans approximately 100,000 light-years, making it slightly larger than the Milky Way, yet the space between the core and the ring appears almost completely empty. Astronomers still debate its origin, as the typical mechanisms for ring formation, such as galactic collisions, do not seem to fit the perfect symmetry observed here. Inside the gap between the central core and the outer ring, a second, much more distant ring galaxy is visible, representing an extraordinary cosmic coincidence.
Now observing WR104. WR104 is a stunning binary star system consisting of a massive Wolf-Rayet star and an O-type companion orbiting each other every 220 days. The colliding stellar winds from these two celestial giants produce vast amounts of dust that are swept into a rotating spiral pattern by their orbital motion. This intricate pinwheel structure is a rare cosmic phenomenon and represents one of the final evolutionary stages before a supernova event. Due to our specific viewing angle, we are looking almost directly down the barrel of this rotating spiral, which has led to scientific debate about whether a future gamma-ray burst from this system could be aimed toward Earth. Now observing Necklace Nebula, PNG05.2-03.4. The Necklace Nebula is a striking planetary nebula formed by the interaction of two closely orbiting stars. One star, having aged into a red giant, shed its outer layers, which were then caught and spun into a ring by its smaller companion. This celestial ring is adorned with bright clumps of gas that resemble glowing diamonds on a necklace, created by the intense ultraviolet radiation from the central binary system. The two central stars are so close together that they orbit each other in just 1.2 days, essentially living inside a shared envelope of gas. Now observing Stephenson 2-18. Stephenson 2-18 is currently the largest known star, with a radius estimated at 2,150 times that of our Sun. Located within the Stephenson 2 open cluster, this red hypergiant shines with nearly 440,000 times the luminosity of the Sun. Its immense size places it at the theoretical limit of stellar volume, making it a crucial object for studying late-stage massive star evolution. If you replace the Sun with Stephenson 2-18, its outer edge would extend beyond the orbit of Saturn, swallowing Mercury, Venus, Earth, Mars, and Jupiter in the process. Now observing Gomez's Hamburger, IRAS 18059-3211. Gomez's Hamburger is a sun-like star in the final stages of its life, shrouded by an expansive, edge-on disk of dust that obscures the central star. This dark equatorial lane bisects the light from the star, creating two distinct glowing lobes that resemble a celestial sandwich. This unique orientation provides astronomers with a rare, unobstructed view of the distribution of cold dust and the physical processes involved in the transition from a red giant to a planetary nebula. The central star is completely invisible. We only see its light as it reflects off the dust clouds located above and below the dense equatorial disk. Now observing WR140. WR140 is a rare colliding wind binary system consisting of a massive Wolf-Rayet star and an O-type companion star orbiting each other every 7.9 years. When their powerful stellar winds collide during periastron, they compress the surrounding gas into dust, creating a new concentric shell of material. This periodic interaction produces a series of nested shell-like structures that expand outward, effectively acting as a cosmic record of the system's orbital history. The James Webb Space Telescope revealed that the dust shells produced by WR140 are shaped into unique, squircular geometric patterns, with at least 17 visible rings representing over 130 years of dust production. Now observing NGC 6302. NGC 6302, commonly known as the Butterfly Nebula, is a bipolar planetary nebula featuring one of the most complex structures ever observed in space. At its center lies a dying star that has reached temperatures of about 250,000 degrees Celsius, making it one of the hottest stars in the Milky Way. The wings of the butterfly are actually vast clouds of gas and dust ejected by the central star at speeds exceeding 600,000 miles per hour. Despite the central star's intense heat, it remains hidden behind a dense torus of dust and ice, which forces the escaping gas into the distinctive butterfly shape we see today.